Hello, hello. Here is the video going over your Unit 4 test review over systems of equations. Questions 1 through 4 have these directions. It says solve each system of equations and show your check by plugging your solution back in. You must do at least one graphing, one substitution, and one by elimination. So you are choosing which method you're going to use to solve the system. You do not have to do all three methods for each question. You're just picking one method and going with it. Now, depending on how your system is set up, it might be easier to do one method versus another method. So if I look at number 1, I can see that my equations are in standard form with x and y's on the same side of my equation, and they're stacked on top of each other. So when I look at that, my brain automatically goes to elimination. So I'm going to go ahead and solve this system by elimination. How do I spell elimination? Elimination. Okay, so I'm going to pick one of my variables to eliminate. It doesn't matter which variable you choose. I'm going to go ahead and eliminate my x's first. So I'm going to multiply the top number by 2. That's going to create a positive 10x. And I'm going to multiply my bottom equation by a negative 5 because that's going to create a negative 10x. So with elimination, your key is to create the same number in front of your variable but with opposite signs. So they actually eliminate. I'm going to go ahead and rewrite both of my equations. So for my first equation, I have 10x plus 4y equals 2. For my second equation, when I multiply everything by negative 5, that gives me negative 10x minus 15y equals negative 35. Now I can see that my x's are set up to eliminate, so I can add my equations together. That leaves me with 4 minus 15 is negative y equals negative 33. Divide both sides by negative 11, and I get y equals 3. Now that I know that y is 3, I can plug it into either of my equations to solve for x. I'm going to go ahead and plug into the first one. So I have 5x plus 2 times 3 equals 1. And I can continue to solve. Subtract 6 from both sides. That gives me 5x equals negative 5. So x equals negative 1. So my solution is going to be the ordered pair, negative 1, 3. Now, I do want you to check your solutions. So in order to check your solutions, what you're going to do is you're going to plug them into both equations. So I'm going to start by plugging into the first one. So I have 5 times negative 1, since x is negative 1, plus 2 times 3, and I want to see if that equals 1. So I'm going to go ahead and simplify. That gives me negative 5 plus 6. Negative 5 plus 6 most definitely is 1, so it works for the first equation. I'm going to do the same thing. I'm going to plug into my second equation. So I have 2 times negative 1 plus 3 times 3, and I want to see if that's going to give me 7. So that's negative 2 plus 9, which is 7. So the solution for this system is indeed negative 1, 3. Okay, number 2. So if I look at number 2, I can see that my y's are isolated, so I could do substitution, but that fraction is freaking me out a little bit. I don't want to solve by substitution when I see fractions there. So what I'm going to do with this one is I'm going to solve by graphing. So I'm going to make a note. This one I am solving by graphing. Now, in order to graph, I need my equations in slope-intercept form, which they are. So this first one, my slope is negative 2, and my y-intercept is 0, 2. So I'm going to go ahead and start at 0, 2, and my slope is negative 2, so I'm going to go down 2 over 1, and I'm going to go ahead and fill my entire graph with points. That way I have an accurate line. Okay, now let's draw the line. So there is our first equation graphed, and let's graph the second one. So for my second one, my slope is 1/3, and my y-intercept is 0, -5. So I'm going to start at 0, -5, going to go up 1 over 3. And I've already found the intersection points. So I can go ahead and draw this line, and I can see where my two lines intersect, and that is going to be my solution. The ordered pair for that is at 3, -4. Now once again, I do want you to check. So I'm going to take this 3 and -4 and I'm going to plug it in. So my first equation is y equals -2x plus 2. So where I see the y, I'm going to replace it with -4. Where I see the x, I'm going to replace it with 3 and hope that it gives me a true statement. That gives me -6 plus 2, which is -4. So it works for the first one. For the second one, where I see a y, I'm going to replace it with -4. Where I see an x, I'm going to replace it with 3 and see if it works. 1/3 of 3 is just 1. 1 minus 5 is -4. So that solution is correct. Okay, number 3. So number 3, what I notice is I have one equation. The first equation is in standard form. The second equation has a variable already isolated. I have y equals -3x plus 7. So when I have a variable isolated already, I'm going to go ahead and solve by substitution. So I'm going to circle what that variable equals. I'm going to draw an arrow to where I'm going to substitute it. So I have 4x plus 2, and instead of y, I'm going to replace it with -3x plus 7. And then I can continue to solve. Going to distribute, so 4x minus 6x plus 14 equals 16. I can go ahead and combine my like terms. 4x minus 6x is -2x plus 14 equals 16. Subtract 14 from both sides. That gives me -2x equals 2. So x equals -1. I'm going to go ahead and take that and plug it into my circled equation. So I can solve for y. That gives me y equals +3 plus 7. So y equals 10. So hopefully my solution is -110. But I'm going to double check it by plugging it into both of my equations. So I have 4x, but I think x is -1, so I'm going to replace it with -1, plus 2y, and I want to see if that gives me 16. That gives me -4 plus 20, which is most definitely 16. All right, for my second equation, I have y equals -3x plus 7. So where I see the y, I'm going to replace it with the 10. -3 times x plus 7. That gives me 3 plus 7, which is 10. All right, so we got it right. Number 4. Number 4, I can see that my equations are stacked nicely on top of each other again in standard form. So for this one, I'm going to go with elimination again. And I'm going to choose to eliminate my x's. So in order to eliminate my x's, I'm going to go ahead and multiply my top equation by -2. I'm going to rewrite both of my equations. So I'm going to multiply everything in the first equation by -2. That gives me -4x minus 6y equals +6. For my second equation, I'm not multiplying by anything, so I'm just going to rewrite it. And I can go ahead and combine. My x's eliminate. My y's also happen to eliminate. That leaves me with 0 on the left-hand side equals 10. Well, does 0 equal 10? Of course not. So this right here is no solution. Let's say you ended up with a true statement of like 10 equals 10. then you would have infinitely many solutions. And since this one has no solution, there is nothing to check. All right, number 5. So number 5, well, I guess it says number 9. So number 9, it says, for problems 9 through 10, check to see if the ordered pair is a solution to the system. So this just goes back to plugging it in. So where I see an X, I'm going to plug in a 5. Where I see a Y, I'm going to plug in a 2 and see if it works. I do need to plug into both of my equations because it needs to work for both of them. So I have 15 minus 4, which is 11. So far, so good. Let's go ahead and plug into the second equation. I have 2 times 5 plus 2. See if that equals negative 3. 10 plus 2 most definitely does not equal negative 3. So this one is not a solution. Let's do the same thing for number 10. Now please be very careful with number 10 as you're plugging it in because we have so many positives and negatives everywhere. So I have 6 times negative 1 minus 3 times 2, and I want to see if that equals negative 12. That's negative 6 minus 6, which is indeed negative 12, so it works for the first one. Now for the second one, I would recommend putting these 1s there. That way you know you're multiplying by negative 1 each time. Otherwise, it can get a little confusing and tricky. So I have negative 1 times 1. Negative 1 is positive 1 minus 2. 1 minus 2 is negative 1, which works. So this is a solution. Now, if you didn't put this negative 1 in the front, you may have calculated it incorrectly, and then you would tell me that it is not a solution. So just be careful with that. All right, application problems. So the first thing you want to do is define your variables. From there, we can set up our equations, and then we can solve. So at a restaurant, the cost for a breakfast taco is... cost for a breakfast taco and a small glass of milk is $2.10. So let's say a breakfast taco and a small glass of milk. The cost for 2 tacos and 3 small glasses of milk is $5.15. What is the cost of 1 taco? So I'm going to define my variables. I'm going to let X equal the cost of the taco, and Y equals the cost of the milk. So when I buy 1 breakfast taco and 1 glass of milk, that costs $2.10. When I buy 2 tacos and 3 glasses of milk, that costs $5.15. So there is my system. Now I want to solve, and my question says, what is the cost of 1 taco? So taco is the variable X. So what I want to do is I want to solve for X. So I'm going to go ahead and eliminate my Y's. So I'm going to multiply my top equation by negative 3, and that'll allow me to solve for X. So I have negative 3X minus 3Y equals negative 630. My second equation, I can go ahead and just rewrite since I did not multiply by anything. Equals 515. And that gives me negative 1x, my y's eliminates, equals negative 115. Divide by negative 1, and I get x equals $1.15. So the cost of the taco is $1.15. Now, if you end up eliminating your x's and you end up solving for y first, that's perfectly fine. Just plug it back in to solve for x since you are trying to solve for the cost of the taco. All right, number 12. A large pizza at Palazzo's Pizzeria costs $6.80 plus 90 cents for each topping. The cost of a large cheese pizza at Guido's Pizza is $7.30 plus 65 cents for each topping. How many toppings need to be added to a large cheese pizza from Palazzo's Pizzeria and Guido's Pizza in order for the pizzas to cost the same, not including tax? So I'm going to go ahead and highlight. Palazzo's is $6.80 plus 90 cents per topping. Guido's is $7.30 plus 65 cents per topping. So I'm going to go ahead and identify my variables. X is going to be the number of toppings, and Y is going to be the total cost of the pizza. So for Palazzo's, Y equals $6.80 plus the 90 cents per topping. For Guido's, it is Y equals $7.30 plus 65 cents per topping. Okay, now if I look at these two equations, I can set them equal to each other. I can solve by substitution. I can also see that my question says in order for the pizzas to cost the same. So there's a little hint. So I can go ahead and set these two equations equal to each other. So 6.8 plus 0.90x equals 7.3 plus 0.65x. And then I can go ahead and continue solving for x. So I can subtract 0.65x from both sides. That gives me 680 plus 0.25 equals 730. I can subtract 680 from both sides. That gives me 0.25x equals 0.5. So x equals 2. So that means they can have two toppings in order for the pizzas to cost the same. Essentially, I did do substitution. There you go. And then their equations equal each other, and then you can continue to solve. Okay, number 13, explain why the system shown below has no solutions. That is because the lines do not intersect. In order for a system to have a solution, the two lines have to intersect, and these two lines do not intersect, so they do not have any solutions. Number 14, explain why the system below has one solution and what is the solution. So it has one solution. Let's see. The system has a solution because the lines intersect. And the solution is the ordered pair where the two lines intersect, which looks like at 1, 2. All right, so there is your review video. Hopefully this helps you get prepared for your upcoming test. Good luck on your test.